Thanks, Con. And thanks everyone for joining us today. My name's Steve Moon. I've been working with Essential Software for the last 17 or 18 years now. And before that, I was actually a customer of theirs. So I was using manufacturing software for a couple of different companies. One was called Certa Mattresses that was local over here in Vancouver, BC. And the other was Advanced Wire Products, which is a current customer of ours over on, it was on Annacis Island. They moved a little bit and they're in Burnaby, not far from, or sorry, they're actually in deep Surrey now. So that's a little bit of my background. And we're going to dive into this. I'm just going to turn off my camera so I'm not distracting you all with my crazy arm waving and gesturing as I speak, as I tend to do. And we'll launch right into our shop floor scheduling webinar here. So most companies that we speak to can explain in a lot of detail the consequences of actually not scheduling very well. So I keep hearing stories about low productivity and then cost issues due to rework, and even just poor overall customer satisfaction because of missed delivery dates. And these are just a few of the recurring themes that we have. So it's easy to understand how a robust planning and scheduling system can help you to meet demand and optimize your resource use, and mainly just deliver your products on time and at a lower cost. But what makes for an effective scheduling system? And how would you even begin to implement one? And those are the questions that I'm hoping to be able to answer for you in this webinar. So a good shop floor schedule needs to be accurate and reliable and make the best use of your resources. The output can be super simple. These are two of the things that we see quite a bit on companies that haven't really implemented a scheduling system yet, or think they haven't implemented one. But really they have. They're using a simple Excel spreadsheet like you see there, or they've got a big whiteboard that's sitting, either in the office someplace or on the shop floor. So everyone knows, what needs to be done. So the point is that the output can be really simple, like this diagram, where we're showing different things. But if you think about it, even with something simple like this, there's a lot of information that needs to be processed. There's due dates, there's supply order dates. And if you have a broken machine or maybe a key employee that misses a shift, all of that stuff can throw out even your best laid plans. And the more variables that you have in your manufacturing environment, then the more you need to rely on accurate and timely information to produce your plan. A good ERP system will give you a central place to maintain all this information and then process it into a schedule that you can rely on. Now, ahead of this webinar, I received a bunch of feedback from some of you, and I know that shop scheduling is a pretty hot topic. So I was really trying to incorporate your questions and themes into the presentation today. Just keeping in mind, I know there's a pretty diverse audience here. So some of you people haven't even seen the system that we generally implement for this, which is Infor Sightline. And you haven't even seen that, but others I'd actually consider almost experts or actual experts in ERP. So keeping that in mind, I've got some things here that go into a lot of detail for that crowd, and I've got some things that are much higher level to try to keep things, moving along for everyone in the audience here. So the agenda that I put together is going to be looking at, first of all, some planning tools, where we look at best practices, manufacturing and control. And then we dive into some Sightline specific things that can help you achieve your goals. And then next we'll be looking at resource allocation. How do we actually set up a system to model and simulate a real manufacturing environment? And we're going to bring it to life with a few common scenarios, and hopefully that helps you on your journey. Then we're going to be looking at ways that we can actually visualize the schedule. So we'll look at some common tools that we use for seeing the schedule, for examining capacity and communicating back to our shop floor the different things that we need to have them working on. And then finally, we're going to wrap everything up and we're going to try to explain how you can implement this. How do you do your environment modeling? How do you work your plan? What do you need to do to tie it all together and make it work? So now let's dive in. And we'll discuss manufacturing controls in general, and then look specifically at some Sightline tools that can be deployed in that context. Manufacturing companies recognize demand for their products, plan the resources required, and then control the production in alignment with an overall strategy. The strategic planning that happens at the very highest level of the pyramid asks, how are we going to compete? Are we going to compete on price? Are we going to compete on quality? And what's the actual niche that we're trying to fill? I was talking to our director of operations, Brett Mewett, who also teaches at BCIT here locally, and he's always got a few stories to tell, and he's a car guy. So what we did was he was telling me about Rolls-Royce. So Rolls-Royce, for example, doesn't even try to compete on price. And I found out that they actually source the best leather to make their seats by enforcing strict purchasing policies, just to ensure that the cows can't get pregnant and don't live behind barbed wire fences. And this is just to make sure that there are no stretch marks or scratches on their skin for when they go to upholster the car. And apparently, we looked it up, and it takes 15 to 18 bulls to make the upholstery that goes into one single Rolls Royce. They use the bulls and they get around the pregnancy problem. At this top level of the pyramid, we don't really see too much detail yet. And as we start to move down the pyramid, you'll start to see a shorter time horizon, but with more and more detail at each level. The top strategy forecasts a general sales volume. And as you move into your tactical planning area, well, then we're starting to look at families of products. If we're Ford, we're breaking down our vehicle lines into pickup trucks and SUVs and sedans, and the detailed models that make up our master production schedule that let us start to implement our material requirements planning. As we move further down, we're looking at a shorter time horizon, and we're about to move into execution, and then we're scheduling our shop floor based on your capacity. And finally, as we come down to the very bottom of this pyramid, you're not planning anymore, you're actually doing. So you're executing your plan on the shop floor. So Infor's Cloud Suite Industrial includes the ERP system called Sightline that's been built on decades and decades of manufacturing and scheduling experience. In Sightline, material planning and shop scheduling are separate processes. Material planning happens near that top of the planning pyramid that we just saw as we begin our tactical planning. And then the shop scheduling part happens near the bottom as we're about to execute our schedule. Some of the planning tools that we have at our disposal can accomplish both planning and scheduling, and others only one or the other. At kind of the two opposite ends of this spectrum, we have MRP, material resource planning, that only does the material planning, and then a scheduler utility that only does shop floor scheduling. In the middle, you have two different types of APS, which can do both material planning and shop floor scheduling, and can plan using either finite or infinite capacity modeling. The scheduler utility can be used with any of the planner tools that are above it. We're going to be diving deep into these different combinations and looking at common scenarios with an emphasis on the shop floor scheduling part. First, let's look at MRP only without scheduling. Unlike the APS or advanced planning and scheduling, MRP doesn't consider things like delays or resource capacity or shifts. The responsibility is always with you, the planner, to make sure that your shop floor has the available capacity to work your plan. MRP generates planned orders and exception messages to help you implement an accurate plan. It's been around for a long time. Black & Decker was the first company to use it back in 1964, and it's still a popular choice among manufacturing companies today. MRP has no ability to project when a supply order might be ready. It uses backwards planning, starting at the due date for the requirement, and then backwards plans to the date that it's needed. It'll plan activities in the past too, and tell you just how late you are so far. Because it plans only materials, this leaves you on your own to manage your shop floor with any external methods that you have, independent of your material plan. Now, if you're running MRP and you wanted to start scheduling your shop floor inside a Sightline, Let's look at what this actually means. So in a nutshell, it means setting the start and end times of your operations on every job. So this example shows a job order in Sightline with the header and the amount that you have released and the status of it, and then breaks it down into all the individual operations. These are the operations that are required to make the part. Since we have start and end dates that are sitting on each operation, I can tell at a glance that this job is already being scheduled. And these start and end dates reflect the ability or the availability of resources and the amount of time that is expected to consume them at each step. So how does scheduling work? Well, we know that MRP uses backward scheduling to plan your shop floor and Sightline. Now we need to introduce a new tool called the scheduler. The scheduler schedules jobs forwards in time, starting at the current date and time, and then scheduling out until finishing the last operation of the last jobs. You can't use the scheduler to backward schedule. So you can't be configuring it to start from the last operation and work backwards in time until reaching the first operation. It only works forward. Now you release the manufacturing orders as suggested by MRP, would be today's date, and then the scheduler schedules them according to the actual availability and capacity of your resources. We'll get into exactly how this is done a little bit later. Okay, so that was MRP and then MRP with the scheduler. Now, what about APS? So APS is the solution to a really specific goal. You want to make a promise and keep your promise. And it does this in 3 different ways. First, it helps you make a good promise when you take the order by considering all the different factors in your environment. Then it helps you plan supply orders to arrive just in time to fulfill that promise. And finally, it'll alert you if you're at risk of not keeping your promise. In the ideal world, you can let your customer know that when they'll have their order, then they agree to the date, and then you can deliver it in full on time as promised. Now, the inputs for MRP and APS are pretty much the same, but APS looks at things differently and helps you plan proactively. Just like with MRP, APS attempts to backward schedule orders from the day that they're required. But unlike MRP, if it hits any dates in the past, then APS will forward plan to help you forecast when the order will be available. Now, here's an example of how it works. We see the demand in the system here in the form of a customer sales order with a requested due date on it. Zoom in a little bit so you can see. So here we have like a customer order. It's got a status of ordered. It's got the order date, and we've got a due date over here. When you're running APS, any place where you see a demand in the system, you'll also see a projected date, and this date is calculated by APS. You'll also see a button that's called Get CTP or Get ATP, depending on whether you're running finite or infinite APS. CTP is running finite, so that means it's considering capacity when it's projecting your due date. Okay, so that's capable to promise. You can think of it, this is wrong, but you think of it as C for capacity. ATP, available to promise, is exactly the same, but it doesn't consider your shop floor capacity. It only considers material availability and routing times when calculating that projected date. Let's go ahead and press this. So we're going to ask the system here, when can we have it by? So we notice that the due date is June 12th, and it comes back and says, no, June 12th is the due date that you have, but you could accept the projected date of September 19th. Okay, I can confirm this new date by pressing yes. Do I accept it? Yes. And then all it does is change the due date for me to match the projected date. And this is typically the workflow that you want to have. I could also cancel it because maybe I think that this date is a little bit too far in the future, and I know we can make it a little bit faster. So let's go ahead and cancel it, and then we'll fix whatever we think is wrong in the system that's causing it to give us false information in the planning system. And then we can go back and do this exercise. It's meant to be able to do it while you're talking to a customer, or maybe you cancel out of it because you're answering an email, and then you're going to go in, fix what's missing, and then tell them the actual due date that you can have it in. There's also a no button. So you can say, no, I want to keep planning to make this due date. And if you're doing that a lot, then what that means is you're telling the system you can actually have it on that date, but you'll figure out why. So that's an option as well. Usually this is enough if you're just working in order entry here. If you wanted to take it a step further, you could look at the planning details. What this chart shows you, we'll get into some of the structure of things a little bit later, but this shows you basically your gears, which are your materials, and then it shows you your drills, which are your operations. And it gives you kind of a waterfall chart of all the days and the individual time buckets of when things need to be ordered and why. If you look over here, it's got the start and end dates. Anything that you see in red is something that's projected a delay. And if you look at the delays, you see this is delayed by 1.5 days. This is delayed by 3 days. And you can resolve your constraints or your bottlenecks one by one to try to get you to a better place. So anything that you see in red here is causing a delay. And this just is an insight into what the APS system is telling you. It considers all of the demands and all of the supplies that are already in the system. It looks at your capacity. It sees this particular delay that we were pointing out, this 3-day delay, is at a specific work center, and you can drill into details on that. So we're running into a capacity issue with this particular order. It does this all on the fly. So if we change the quantity, if we change the due date, we can do what if scenarios very quickly and easily just from the order line. Okay, note that when you have bottlenecks like this, it can cause APS to push out subsequent material orders because of the delay. Now, if you're running APS and you want to schedule your shop floor and sightline, you have a couple of options. As we've seen, APS understands both your material requirements and your shop floor's capacity constraints. So the very first option is just to let APS manage your capacity and set the start and end times of your operations. To do that, you use a flag called Use Planning Output for Scheduling. Now, the second method that you have is you can use the exact same scheduler utility that we used with MRP. As this says here, there's some functions that the scheduler can support that APS doesn't. And here are some examples of the reasons why you might want to use the scheduling utility. So for example, you might want to manually resequence work or split it across multiple resources. You can also schedule based on setup requirements. So a typical scenario for this might be a paint booth where you want to sequence work according to the setup required for particular colors. So you can specify that when you switch from a lighter color to a darker color, for example, that'll do a shorter lead time, or that'll have a less impact on your setup time than switching from a darker color to a lighter color, because you have to do the setup and the cleanup in that order. You can also define very granular reasons or rules for when to select specific resources and how the work is actually prioritized. So you saw how every demand has a projected date that can be monitored, and this holds true for a job order as well. So this is my job order. I've got a projected date. The difference is once a job's released for production, APS no longer updates the projected date on the job like it does for a customer order. So instead, as you've seen before, the scheduler will update the operations, all the start and end times for each operation based on your capacity. And then it'll set this projected date to be equal to the last operation or the end date of the last operation in your job. Okay. Any questions in the chat there? Anyone want to throw anything in? Do you have anything, Con? Let me just have a quick look.
Oh. We don't have any question right now.
Okay.
Yep.
All right.
Yep.
Thanks, Con. I'll just
no worries.
All right. So now that we have a better handle on some of the planning tools that we have, we can dive in and look at the resource model that Sightline uses and how it can be set up to solve for some specific challenges that you might face. Okay, some of you may have seen this before. It's was presented by a fellow named Greg Keating at the Sun Conference, the Sightline User Network, a few years ago. It's a great analogy, so I thought I'd use this as well. So in the center here, there's a stamp part, and this happens to be used in every 8-cylinder Ford engine that's ever produced. So you can think of engines for the Ford Mustang or the Ford F-150. Now, to make this stamp part, we need 4 things. We need raw material to go into it. We need a press to stamp the part. We need this part-specific die that's going to stamp the part for us. And we need a human being who can operate the press for us. Now, Sightline uses what we call a bill of manufacturing, and that contains the manufacturing operations that are needed to produce this part, which are these individual routing steps. Now, if the first operation is stamping, we would add the raw material in here. And this is a very simple part, but if it's a little bit more complex, then we might have an operation here for welding. And then we would add the parts that we weld to it in here. And then maybe this last operation could be packaging or final assembly, and we can add the extra components that go into that operation. Now, each operation occurs in a location that we call a work center. In this diagram, we see several distinct areas that might correspond with an operation in our bill of materials. So over here, we've got, maybe this is our stamping area, and then we have a welding area, and then we have our final assembly and packaging areas as well. So each operation needs to occur in a work center. Now, if we look at our stamped metal part, we've created a stamping work center here. And within that stamping work center, we can draw from different pools of resources that are required to do the work. Each one of these, we call them resource groups. They could be in a different category. They could be a labor resource group, a machine resource group, or an other resource group. And that's where we put our dies. You could potentially have more than one group so you might need 2 workers from different organizations, or you might need 2 different machine groups to perform the operation. That's a possibility as well. In this case of our stamped metal part, we have 3 workers here, and we have 4 presses here, and then 4 dies. Now, how do we allocate these resources to do the work? Because our example has 4 presses, but only 3 press operators to do the work, we can do what's called resource allocation sequencing. We're basically flat out on labor, and if we are, then we're constrained on that labor. So this resource allocation sequencing rules, these are our tiebreakers. So the first one is it looks at APS order priority settings. So which of our demands have the greatest priority? So for example, a forecasted demand or maybe a safety stock replenishment might have a lower priority than a customer order. Then we look at the due date for a demand. When was it due, or when is it due? And then when was it created? So is this a first in, first out situation? Then we look at the order number and then the item number. And here's a simpler way to visualize this. At the very top level here, you have your stamped part. This part runs in a stamping work center. In order to complete the work, I need to pick a machine from our machine pool and a person from our labor pool. This bottom level is where we're actually managing our capacity and where the system will be assigning resources from. So what happens if I have a part that can only be run on a unique machine? Here's our stamp part. We have 2 machines, and they can run on either of them. But in this case, the F part XYZ can only run on machine number 2. So it's got some sort of unique abilities, right, that the other machine doesn't. We can't just create another resource for it because I only have one machine number 2. So this is how you can structure it. You create a different resource group, one that only has machine number 2 in it. And this way, whenever part XYZ comes, it needs to be run on this machine number 2. The same is true with labor. It's just as common where you would have a group of highly skilled operators or ones that are specifically certified to be able to work on specific jobs, but then they can be part of a larger labor pool of general workers that could work on any job. Okay, so this is for like the more advanced people here. So earlier we talked about how there's some very granular rules that are only available if you're using the scheduler tool. So we'll look at this as opposed to the simpler rules that are governing APS. And the scheduler specific rules are under 3 categories. Now, the first category comes into play for jobs that are being created and released for production. So first of all, if you haven't released the job, then it won't get scheduled. And then secondly, there's a job release rule that can be set to prioritize the jobs that are set to start on the exact same date. So the scheduler has no effect on jobs that haven't been released, and if multiple jobs need to start at the same time, then you can specify this job release rule. And just like with the APS, there are specific tiebreakers that are based on priority codes, run times, and job sizing, among other things. Okay, now let's look at another scenario after you've released the job. Let's say we need to schedule a resource, but all the resources are busy. So what happens then? Well, we need to queue up the work, and there's 2 different ways to queue up the work. The first is a resource sequence rule. Okay, this is the second category here, and this controls how the loads are queued up based on static rules. So for example, first in, first out, or you can set a job priority to each job, or you can look for the shortest and longest operation time. Not going to get into all the details there. There's a lot of different options that you can use to ensure that the right resource gets chosen. So this is queuing up the rule. And then there's a default, a global sequence rule that's used if there's nothing specified. Right? So you could just leave all these options blank and it'll specify your global sequence rule. Okay, so that governs how the work is queued up at a specific resource. The next and final one, you can look at this. Actually, I thought of a good analogy just this morning. It's kind of like having a desk, sitting at your desk and having an in tray, and people are stacking the orders, right? Or whatever work you have. They're stacking the work on your tray and they're picking a sequence. So that's your resource sequence rule. Okay. Then this comes into play, the resource selection rule, later on when you're looking at that stack of work that somebody went and sequenced for you, and you're deciding what to pull out of the queue. You're picking and choosing there. So maybe you have a way of overriding it, but then also it's a little bit different because you're actually grabbing work and it's based on what's in that stack, what's already queued up. So you can do some pretty interesting things there. So you could say, I want to only take the job with the longest job first, or maybe you want to take the shortest job, and that way get all the small things out of the way before you grab another thing from the queue. So very interesting what you can do. And then finally, we have sort of the opposite scenario from this. The first scenario said all the resources are busy. What happens if you have multiple resources that are available? So then we look at a resource group allocation rule. There's different ways to allocate to that. Most common ways are cyclic, so it just runs in a circle. You can also do kind of a serpentine thing where it runs forwards to backwards. You could look at the longest idle time, or you could look at the shortest setup time. Each one of these categories has at least, I'd say, 10 rules in it. So you can definitely use some very granular rules to ensure that the right resource gets chosen. You can also specify whether you want to reallocate work to another resource if the work is being interrupted. For example, if a worker shift is in. So some very granular scheduling rules that you can get into with the scheduler. Okay, so there's a few questions. Yep, so we're recording, so that's good. Anyone has any questions, feel free to throw them into the chat there. So now we've looked at some of the planning tools that we have available to us, and we've gone pretty deep into the theory of how you can model your shop floor in Sightline, and we've given you a few examples. So now let's look at how this information can actually be visualized so that you can do some deeper analysis and communicate your schedule to your shop floor staff. Now, if you're using APS, and especially if you're using APS to set the schedule for your shop floor, the new production hub that we have available will give your production managers a convenient way to view and analyze the results of your APS planning runs, as well as letting them take specific actions on the areas that need attention. So starting over here on the left, what you have is you have an APS planning summary, and we're looking at the last APS run date, and it tells you in a convenient way how long did it take to run and were there any exception messages. And of course, you can drill into the information, and you can also choose to look at things at a specific point in time. Underneath there, we see the utilization analysis. So you can run this by resource group or by resource, and you can look through and you can drill into the different information as you need to. The results of that planning run also may throw exceptions. So here you're looking at on-hand negative. You've got 33 items that have gone negative because we've set that parameter to allow on-hand negative here. And then we have specific items, 13 of them, that are below safety stock. So those are the exception messages, and you've got one convenient place to deal with them. Down below, you have a demand analysis. And this looks at the demand types, for example, customer orders or forecasts, project resources, service orders for your repairs and maintenance. All of these demands, it looks at them and allows you to drill into them. If you see that there's, for example, 129 demands that are planned, and then you could also deal into the exceptions, which are extremely high in my demo environment here. So I've got 128 demands that are customer orders that are projecting late. So a nice convenient way to look into them. As a production manager, I'm interested in jobs. All 52 of the demands that I have, that are jobs are projected late. So I want to drill into that and then resolve these issues. You have some links to some very common sort of areas of the system that you would go into, for example, the jobs or your resource plan and generating a material planner workbench. And underneath, you have a summary. This is only one of the KPI groups, but I could look at my stop jobs, or in this case, I'm looking at my 15 job releases that are past due that I need to release, soon. And when I select one of them, they appear in the grid below. And in the grid below, I can just look at any of my 15 releases that are past due. I can drill into the job. I can look at my component shortages to see if there's any issues there. Or I can actually release it from here without going to my material planner workbench. Just some interesting features that came out. They're launching some more of these hub forms with the October release as well. We've got about 4 or 5 that are available, including finance. And then in October, they're going to be bringing in a bunch more. Now, here's how a production manager can see the schedule for a shop floor. On the very left here, you see a detailed breakdown of each day, at the top, a detailed breakdown of each day by specific time slots. The bars that you see in gray are off-shift hours. Okay, so this was done on a Monday, and then this day would have been the Sunday. So we're looking at Sunday resources. There wasn't, this one was on shift. These ones were all on shift. And then this one here was actually scheduled. So one of our drying machines works on Sunday. This is a list of all the resources that are here that are available. Now you can filter this list as well by defined groupings if you desire. So you could look at only your assembly workers or only your cutting machines and your CNC machines all as one group. So you define these groups, and then it'll help you plan out your shop floor schedule a little bit easier. Okay, we've set up color coding as well to show any work that's late in red. And of course, I've got a lot of work that's late, as we just saw, all of my jobs are running late. We also have color coding here. So when you select a load, it'll follow it through all the way through the job as the work is scheduled from one resource to the next. In this example, it's a Toyota engine, and it's going through cutting, and then it's going through some forging process, and then it's going to inspection afterwards. And it gives you the timeline of the breakdown as well. Now, if you're using APS to create this schedule, then the information that you see here is maintained by APS. This one in particular is the schedule, was done using the scheduler utility. And if you're doing that with or without APS, then you have the added flexibility to be able to modify, split, and freeze your changes here dynamically as needed. And then here on the far right, you see some information on the operation start and end times, along with the time remaining at each load. Jen asked if we can create the PowerPoint to include the form name. Yeah, I can do that and send it to you, Jen. No problem. I'll make that available too. Okay, this is a utility that helps you check on the load for a particular group of assembly workers. So we're looking at the resource group assembly, which we've defined, and you can see that there are 4 resources within that resource group. Okay. We picked a starting date, and we're looking out 7 days into the future, and we're only looking at group allocations here. So you can see it start to fill in the grid. So it's going day by day because that's the interval that we've selected, and it's going forward 7 days. We can see the on-shift hours that each that the resource groups run on, and we can see the setup hours, the run hours, the backlog hours, total load hours, and the utilization. It's a little easier to see in the graph here. So you can see that this was done on a Friday. So here we are, we're at 51% capacity. And then we had a weekend with no resources on shift. And then we broke it down a little bit. We finished up the bulk of the work on the Monday, and then Tuesday there was a little bit left, right? It would show setup time as well, but I didn't have setup time scheduled here. You also have the ability to look at it from a backlog perspective. So this is showing the utilization going down. You can also show the backlog as it's also decreasing. So you'll notice at the top right, it also has something called an alternative. And this appears in pretty much any of the planning related forms and allows you to create what we call alternative scenarios. So the alternative that you see here, 0, this means that this is your actual plan that's based on your actual resources. Now here I've taken the assembly workers, and you see that I've created an alternative 1 for them. So what I've done is, this is actually a resource group, and I've gone in and created alternative 1. And the difference is here, I've added a 5th assembly worker. Okay, so this is alternative 0. There's 4 workers, and I've created alternative 1 with 1 extra worker. So let's go ahead and see how that runs. So once we run the scheduling utility, now we're looking at alternative 1. So you see what happened is, now on Friday, we're doing the bulk of the work. We only have a little bit more to finish up on Monday, and then Tuesday we're free and clear. So current alternative 0, we've got 3 days worth of work. And then alternative scenario, hiring somebody else or just putting somebody else on the job. Now we're pretty much at 2 people there. You can also run this for for a resource as well. So individual resources instead of by resource group. A good point from Hassan, not getting accurate utilization because the tool is adding multi-resources availability. That's true. So they might run on different shifts. That's certainly factored in as well. So you could run this by resource as well. Good point, Hassan. All right, so we've covered a few different ways a production supervisor can view the shop schedule and check on the workload. Now, how do we inform our floor staff of what they should be working on? The traditional method is just to print out a list of the work and then hand it out. So here we're looking at a resource group dispatch list report. We've got our scheduling window. We're looking at our assembly group, and then it breaks it down by the different assembly workers and tells us what they should be working on, and when they should be finished. And it tells us the status of the job, how many are in the load, what's the quantity at the work center, what was the previous work center, and what's the next one. So when they finish the work, they know where to take it. The other thing we could do is print it out resource by resource. So this one could be handed out to individual employees. So you see I'm logged in, or I'm looking at assembly worker 1, I hand them his work for the day, same information. This is resource by resource. That's kind of the manual way of doing things. Now, on a modern shop floor, what you might be looking at is, here we've got our sort of diagram of the shop floor. And maybe what we want to do is have in here, like an area or a kiosk where people can clock in for the day. So you probably want to have a time track kiosk. This is part of our factory track solution, which is typically included with all new Sightline implementations. So time track will take care of your punch in, punch out, break for lunch, all of that type of time and attendance type thing. So maybe we want a kiosk here if we only have one entrance to our shop. And then you can see that we have 3 different CNC machines that are sitting here. Okay. So maybe what we want to do with these is we want to have 3 shop floor kiosks. So these shop floor kiosks will run our factory track shop floor application, and that'll allow us to punch in and out of jobs and record labor at different workstations, as well as material issues as we pull stuff to be fabricated. Time track also includes a mobile interface called Warehouse Mobility, where you can do your common moves on the shop floor. So you move different products. You can do PO receiving, you can do shipping transactions, all that sort of thing that you might want to do. It's typically made to run on a barcoding device. So it would be attached to a scanner. But you can also run shop floor on floating devices. So a lot of our customers tend to do that. They have a few specific areas they want people to walk to and record their production at, but then they have floating devices as well that can be used at any work center. Look at one of the shop floor interfaces. So here you can see I'm clocked in as a specific resource. I'm David Daniels, that's my name here, in this case, and I'm clocked in as assembly worker 1. So basically when I scan my badge, I'm a resource, and I can have the work scheduled to me as a resource. Because I'm associated to it, I'm seeing a list of all the work that I have that is in my work queue. I could also change this and look for work that's at a specific work center, and I can look at it by resource group as well. So the grid in here fills up with all of the stuff that's being dispatched for me based on, my badge scan. And it tells me how many have arrived at the work center, how many have I completed, and how many have I scrapped. So it gives the information on each job. And I can go in, I can clock into one of these jobs by touching it and then clicking the start option. And then I can end my run and record my production afterwards. I can also view notes and documents and perform job moves on the shop floor. And so this is a list of, because we associated the employee with a resource, then this is really a list of all the work that's assigned for him that he needs to do within, in the order that he needs to do it in. Okay.
Steve, we have a couple of questions. Would you like to answer them right now, or do you want me to address them at the end of the session?
Yeah, maybe if we just do it at the end of the session, because I'm kind of
Sure.
a little lost in the chat here, so I thought it'd be easier to keep up with, but.
Sure.
Okay.
Sure. No worries. Okay. Please go ahead.
All right. So we've seen many, in detail, a lot of the planning tools that you have that's available to you, and specifically how Sightline handles and lets you visualize the planning and scheduling of the shop floor. But let's put it all together now and look at what it takes to make it all happen so you can be successful. So everything is actually simple when you break it down into manageable bite-sized chunks. And integrating your shop floor scheduling into an overall enterprise-wide plan might seem like it's a daunting task, But really, there's only one way to eat an elephant, right? Fight, fight, fight. And we can kind of break down the keys to success or sum them up in two equally important areas. The first one is planning and setup. The planning and setup is involved in modeling your environment. How do you break down the time that's expected to be taken in each step? Where are your constraints? And the second equally important part is your company's ongoing commitment to maintaining this scenario so that you're actually working your plan instead of comparing it against a simulation. When you're modeling your shop floor, there could be many factors that need to be considered. If you're implementing the finite scheduling, then it's tempting to think of everything as a constraint. But as one of our guys, Brendan, reminded me, if everything's a constraint, then nothing is a constraint. A little bit earlier, we looked at a scenario where there are only 3 employees that could run 4 presses. And I mentioned that in that particular scenario, we'd be constrained by labor. If our shop is running flat out, it would make sense that we'd start to see work queuing up on these 3 workers. So when we're modeling, we would probably want to have labor as a schedule driver and then schedule those workers finitely to model the scenario as accurately as possible. From a production management perspective, this resource group is a bottleneck, and it limits your total system throughput. Now let's imagine a packaging operation that needs to occur at the end of every job that runs through your shop. Pretty much any employee could run this machine if they need to, but if you only have one of these machines, then this particular machine now limits your throughput. The point being that even as one constraint is resolved, another constraint will become the critical one. Themes like this are illustrated in Eli Goldratt's book, The Goal, which details a sort of a fictional but very, very realistic struggle of a manager that's in charge of a manufacturing company. So it's definitely worth a read if you haven't checked it out already. So let's say that you modeled your shop floor accurately. You're confident in your routings and your bill of materials setup, and you've dispatched the appropriate resources to execute your work. What could possibly go wrong? This is a quote from a famous production manager who is well known for his ability to dispatch people. Now, Mike's quote doesn't negate the value of planning. It actually underscores a need to be flexible and adjust your approach when things won't go as expected. So it's not just about having a plan, but also about having the ability to react and adapt to changing conditions. We actually repeat his quote a lot in our office when we're talking about implementing scheduling. And even though it seems funny in the context of production management, it actually makes quite a bit of sense. There are often so many things that can go wrong in the production environment. We mentioned a few at the beginning, people not showing up, like machines breaking. So often the key to success often relies on feeding back that information so that the system can adapt to your changing environment accordingly. Now, how do we do that? Dialing things in to model your shop floor is literally only half the battle. Companies often struggle with the long-term commitment that's involved with keeping the planning data current and accurate. This really involves a coordinated effort across multiple disciplines, where, for example, your customer service and your procurement and then production planning and management all need to monitor for demands that are either projected late or late. Each department needs a detailed checklist of how to review potential issues, and some of the examples are shown here. And once these issues have been identified, then we need to take steps to resolve them. The resolutions might be a physical change or a real change, like calling a vendor to expedite a purchase, or it could involve correcting data in the system that isn't valid. For example, you might have an incorrect lead time that might be causing a demand that's projected late unnecessarily, causing the downstream effect of pushing out the shop's schedule. And then finally, if nothing can be done to resolve planning problems, we need to update our system to let it know when it can expect our delayed items to be available, and then replan accordingly. Just a word of caution, because a good ERP system will provide you with a framework to set your production up in, and the tools that will help you enter timely data. If this environment wasn't accurately modeled to begin with, then the effort involved in working your plan will probably seem unjustified, and you'll likely revert to your old way of scheduling. We can put it this way. The challenges that are involved with scheduling your shop floor usually fall under these two categories. It could be that the landscape isn't fully understood, and, for example, you don't know where your constraints and your bottlenecks are, and how long does it really take to produce or purchase a part? Or it could be a part with communication. If a PO is coming in late and nothing can be done about it, the shop manager needs to know so he can reschedule his resources appropriately. This is whether you're using a manual system or using an ERP system. The challenges can occur whether or not you're using something that's sophisticated, right? They say garbage in, garbage out. And as a matter of fact, working a plan that's based on inaccurate planning data will lead to a lot of frustration, especially if you're expecting just an easy fix. If you start with an accurate model and you work your plan in a timely manner, then you can recognize the benefits of optimized resource allocation, minimal production disruptions, and better overall productivity, things that are all critical to staying competitive in a modern manufacturing environment.